Welcome back to We Dared Chemistry. In this lecture, we will spend our brain doing some numericals, so join us whether you are a student or a curious mind. Exercise questions. Problem 2.47 Neon gas is generally used in the signboards. If it emits strongly at 616 nanometers, calculate A. The frequency of emission, B. Distance traveled by this radiation in 30 seconds, C. Energy of quantum and D. Number of quanta present if it produces 2 joules of energy. Given wavelength equals 616 nanometers, 1 nanometer equals 10 raised to the power minus 9 m, so is equal to 616 times 10 raised to the power minus 9 m time equals 30 seconds. Energy for 2 joules quanta, C equals 3 by 10 raised to the power 8 meter per second. Solution. A. Frequency of the radiation. Frequency equals speed of light divided by wavelength. Frequency is equal to 3 times 10 raised to the power 8 divided by 616 by 10 raised to the power minus 9. After calculation, frequency is equal to 4.87 times 10 raised to the power 14 Hz. B. Distance traveled. Speed equals distance divided by time. Distance equals speed into time. Distance is equal to 3 times 10 raised to the power 8 into 30 after calculation. Distance is equal to 9 times 10 raised to the power 9 meter. C. Energy of quanta. Energy equals Planck's constant into frequency where h is equal to 6.626 times 10 raised to the power minus 34. Energy is equal to 6.626 times 10 raised to the power minus 34 into 4.87 by 10 raised to the power 14. After calculation and decimal changes. Energy is equal to 3.2268 times 10 raised to the power minus 19 joules. D. Number of quanta present. 3.2268 by 10 raised to the power minus 19 joules is produced by equals 1 quanta, so 2J will be produced by equals 1 divided by 3.2268 by 10 raised to the power minus 19 into 2 is equal to 2 times 10 raised to the power 19 divided by 3.2268. After calculation, number of quanta is equal to 6.16 times 10 raised to the power 18. Thank you for your attention. Keep studying with We Dared Chemistry.